Hello, today's lesson is on finding the unit rate in graphs, and this is the guided notes. So you're noticing that there's a blank here, and we can also call it the constant of proportionality, also known as the k-value. So let's write that down. Before we begin, let's acknowledge that all of these graphs are proportional. And if you recall, a proportional graph is a straight line. All of these are straight lines that pass through the origin, and every single one of these graphs pass through the origin. So before we find our unit rate, let's investigate what each graph is about. And we can see that our x-axis for this example number 1, the x-axis is talking about the number of baskets, and the y-axis is talking about the price. So we're going to state that as y. Okay, when we find the unit rate, we're going to talk about the y over the x, so y compared to x. So when we look at this, this is the price for a number of baskets. And since we're going to be talking about unit rate, we want to know the price for one basket. And knowing that, this is the easiest type of graph that we can work with. If we're trying to find out the price for one basket, well, we simply go to 1 on the graph, and then I look at where my graph line hits one of these grid marks. So I can see right here above 1, it hits exactly at that little crosshairs of the grid mark. And if I look at it, 1 matches up with 3. So we can say our y value is 3 when our x value is 1. So the unit rate is 3, and more specifically, it's $3 for one basket. Now let's explore example number 2. Again, let's explore what this graph is about. It's talking about flowers for the y, and it looks like the number of flowers. And it's talking about vases. It looks like the number of vases for x. So since when we talk about unit rate, we're always referring to the y compared to the x, our y values is talking about the number of flowers needed for the number of vases. So once again, we're looking for the unit rate. So we're looking for the amount of flowers for one vase. So now let's go to the graph, and I'm going to go to one vase. But when I move up, I can notice that my graph line doesn't hit exactly at the crosshairs of this graph. And so I can't say that 1 matches up exactly with 3. It might be 4, it might be 3.5. It's not exact. So I'm going to go over to my 2. And when I go up, again, this graph line doesn't hit right at a crosshairs, so to speak, of the graph. It's somewhere in between 6 and 9. So if I go over to 3 and up, oh, finally, I can see where above 3 on my graph line hits exactly at one of the points on the graph line exactly across from 12. So if I look at my y value, it's across from 12, and if I look at my x value, it's across from 3. So my y over x, to be exact, is 12 over 3. Now, if I would have tried to use what matches up with 1, it might have been 3.5 or 4. And if I would have tried to use 2, it looks like it's somewhere between 6 and 9. It could have been 7 or 7.5. So when we do this, when we're reading a graph, we want to use whole numbers. So 12 divided by 3 would be 4. So this equals 4. So our unit rate is 4. But more specifically, we're talking about 4 flowers in each vase, or per vase, or for one vase. So now let's look at the last graph. So before we do, let's look at example number 1. When we have a graph that gives us an exact value that matches up with 1, that's the easiest. We can actually read $3 for one basket. And the second example is a little bit more complicated. We did see 1 on our graph, but it wasn't very helpful because the graph line kind of fell in between numbers on our graph. And this last one, wow, we're not even given 1 as a possibility. So we're going to have to use a different set of numbers. Once again, we want to know what the graph's about. So if I look at the y values, okay, what y is talking about compared to what x is talking about. Well, x is talking about square feet, and y is talking about square feet, and x is talking about cement bags and pounds. So I'd have to assume perhaps they're making sidewalk, they're laying down concrete, and so they need cement bags. So we're talking about the number of square feet, and again I'm assuming it's concrete, of concrete, and the number of cement bags that are needed. So our work area, once again, we're always talking about the y over the x when we're working at this. We're trying to find the unit rate, which would mean how many square feet could we pour or get out of, or could we make out of one cement bag. So that's what we're talking about. So if I look at this graph, I don't even have 1 here. So I'm going to go over to my graph line until I can clearly see that my graph line hits right at a grid mark. And I see right there is where right above 50 and 200. This is the first point that I can identify that's on the graph line that hits an exact grid mark. And so now I have 2 whole numbers that I can work with. And we want the whole numbers because it's really hard to estimate the in-between lines on the grid mark, or on the grid. So we're going to call 200 for my y. It's right across from 200. And then 50 for the x. And when we take 200 divided by 50, that's going to equal 4. So our unit rate, once again, is 4. And that means 4 square feet. Once again, I'm assuming it's concrete. From 1 bag of cement. So I hope this was helpful. And now what I'd like you to try to do is try a few of these on your own. Thank you for listening.